So f of x is equal to that, and we want to know the left and right hand behavior. So again, just kidding. There it goes. As x approaches negative infinity, f of x approaches something. And as x approaches positive infinity, f of x approaches something. So you write down what you think that something is. Okay, so as x goes to the left, what's f of x going to do?
Go positive.
Yes, it's going to go up. And then as x goes to the right, f of x is going to go negative, yeah. So the reason why is because that top has a degree of 3. So it's an odd degree, so I know it's going to point in opposite directions. Then the leading coefficient is negative. If it's negative, then it goes up on the right, left, and down on the right. So that's why as I go to the left, it's going up, and as I go to the right, it's going down. So that's what we would say is our reasoning. Odd degree, negative, leading coefficient. That's our justification.
So we won't get any points taken off just for putting that?
I would accept that. If x plus 3 is a factor of f of x, rewrite f of x in completely factored form and identify the zeros of f of x. So x plus 3 is a factor. So that means that negative 3 is a 0. And I would divide that, negative 2, negative 1, 13, and negative 6. And bring that straight down. Multiply, add, multiply, add, multiply, add. And I should get 0 because if it's a factor, it should work out. So it's negative 2x squared plus 5x minus 2. Now we're trying to get the other factors. Negative 2x squared goes here, minus 2 goes here. Multiply the first and last one together, I get a positive 4x squared. Two numbers to multiply to give you 4, but add to give you 5.
4 and 1.
Yep. So 4x and 1x. I had to do the long no fuss method just because there was a number in front of the x squared. So factor out a negative 2x, leaves me with x minus 2. Here there's nothing to factor out, so I have to pull out a 1, also leaving me with x minus 2. So that's x minus 2, negative 2x plus 1, and then don't forget your original factor, which was x plus 3. So there's the completely factored form. But we're also supposed to identify the zeros. So here's 1 0. Set each one equal to 0. X equals 2 is another 0. And then negative 2x plus 1. So x equals 1/2 is also 0. Where's mine? And then sketch a graph using the identified left and right hand behavior and the zeros. Notice all those zeros have a multiplicity of 1. They've only occurred once, so that's good to know. So x is -3, x is 2, and x is 1/2. I know it goes up on the right. Oh, wait a minute. I also know -6 is my constant. So it's going to cross down here somewhere at -6. Something like that. How far up or how far down for those maxes and mins, we don't know. Doesn't tell us on this one. On the other one, it told us the maxes and mins, but it didn't tell us the zeros. Okay, D. Suppose a cubic polynomial function with a positive leading coefficient g of x is such that x equals -3 is a root. Multiplicity of 1. X equals 2 is a root of multiplicity 2. Sketch a possible graph of g of x and explain how you developed your graph. All right. So I have zeros at -3 and 2. I know that at 2, it has a multiplicity of 2. It has a positive leading coefficient, and it's a cubic. So positive leading coefficient and cubic tells us what about the
It's going to go up on the right,
down on the left. If it has a multiplicity of 2, what's going to happen? It's going to bounce. Or also they call that tangent to the x-axis. I don't care which terminology you use. Bounces is perfectly fine. Just probably in the multiple choice, it would say tangent to the x-axis. So that's why I want you to be familiar with both. All right, so it's going to go down on the left, up on the right, and over here at 2, it's got to bounce. So, well, it might help if I go through the point. No. Something like that. And this is a pretty good explanation. Oops. I might have another free response question. Yes, I do. Okay, next free response question. Table of values for a polynomial function g of x is shown below. Use the equation of g of x and the table to answer the questions that follow. So 2 of the zeros of g of x are specifically listed in the table. That's nice to know. What are those 2 zeros? Okay, so those 2 zeros are -1, 0, and 2, 0. Then, what does the multiplicity of each 0 give a reason for your response? I'm actually going to separate this out a little bit. Okay, so what's the multiplicity of this one?
1.
1. Why?
it goes straight through.
Yeah. It goes from positive to negative. It goes straight through. Yes. Multiplicity is 1 because g of x changes signs around